Hi, chemistry students. This is Mr. Tro coming to you from Buffalo Grove High School. My cameraman is the infamous Mr. Van Grandel. Say hi, Mr. Van Grandel.
Hello, Mr. Van Grandel.
Very good.
Yeah.
Today, we're going to do a little experiment. It's a virtual experiment because we have no other choice, but we're going to do a little experiment called the Chem Phenom, where we're going to put together a bunch of chemicals. Now, the chemicals we're going to use are calcium chloride, CaCl2, and if you look at this, Mr. Van Grandel, calcium chloride is a white solid. It comes in tiny little particles like that. Okay, so it's large crystals, white solid. We also have sodium bicarbonate. You might know it as baking soda. It's also a white solid, but it's a fine powder. Okay, so we have two white solids, different substances. We have something called phenol red. Phenol red is what we call an indicator. It's phenol red, which actually comes from a plant, but it's a solid that's dissolved in water. So it's a mixture, kind of like if you were to make lemonade and you dissolve sugar and lemon juice and all that into water. It's a mixture. So this contains phenol red and water. And since those are together, we also have a water bottle if we just want to look at what water does, okay? So our plan today is to take and mix all these things together at first to see what happens. And then we're going to do individual experiments to see what combinations cause what you see, okay? So to start, we're just going to simply do an experiment where we take all the chemicals and put them into a baggie. So we got a Ziploc baggie here. I'm going to take some calcium chloride. I'm going to put it into the bag. I'm going to put it into one corner of the bag. So I don't want this to mix with other solids. Okay, so that's going to be down in that corner of the bag. I'm going to use a different spatula for my sodium bicarbonate. That I'm going to put up here. If Mr. Van Grandel looks at or zooms in here, you can see that I haven't mixed the two solids yet. They're separate, so nothing is reacting. Now I'm going to put the phenol red in. Now, as I said before, phenol red is phenol red and water. So this is actually two substances in one. I'm going to try to squirt that into the corner of the bag over here, away from everything. Okay. And then I'm going to flatten the bag out, Ziploc it, and then we're going to mix these together and we're going to see what happens. Okay, so I'm going to bring them together. Mr. Van Grandel, do you see anything happening?
We look like we've got a color change.
Sure, it looks like it changed to a yellow. If you zoom in, maybe at home you guys can see, what does it look like is happening inside the bag?
Looks like we got some bubbles or something in there.
Definitely, we got some gas being produced. Okay, so we had a color change to yellow. Now, if I feel the bag right here, it feels kind of cold to the touch, right? But I feel the bag over here, it feels kind of warm. I'm gonna keep mixing this together. And as I do that, I feel that there are parts of the bag that are warm and parts of the bag that are cold. Okay.
Do we have any chunkiness in there?
Well, the funny thing is, as I mix it, the solids appear to be disappearing. Maybe they're dissolving away, kind of like sugar and water, or maybe they're undergoing a reaction and they're becoming something else. There's no way for us to know that right now, but we can certainly observe four things, okay? So if you're following along at home, there are four changes that we observed when we mixed these chemicals together. Okay. One of them was that there was a temperature increase in part of the bag. So the temperature went up. Another one was the opposite, the temperature went down. The third observation was that there was a color change that went to yellow. And then the last one was that we generated bubbles. There was a gas produced. Okay. So at this point, we're going to pause the video and then we're going to move on to the next part of the experiment. And we're back.
All right there, ladies and gents. So what we're going to do at this point, we're going to try to just exactly figure out which of the chemicals are doing what and what's causing the different things. So the first thing we're going to try to do here is that we are actually going to take the calcium chloride, and I'm going to get a little bit of that. It's kind of white and chunky.
He's going in for seconds.
I always go in for seconds. It's just
Yeah.
part of the job. And then we're going to take the sodium chloride, bicarbonate, sorry.
That was a good helping right there.
Okay, so we got the two of those guys together. They're actually not together yet. They are on kind of opposite sides of things. And then we're going to kind of put them together. We're going to see what happens here. We're going to try to get all the air out of the bag, so we're going to squish it down.
Oh, this is so exciting. All right, shake it up. Oh, man. Oh, that is one way you can shake chemicals together, folks, when you're in lab.
As long as we got a seal on there, then you can do that.
Wow. This is pretty exciting.
Um,
Do you feel a temperature change at all?
I don't really feel too much going on here.
No? Any bubbles, any color change?
They still look white, and we still got some.
Oh, the solid's still there.
The solids are solids.
Well, it looks like that was not very exciting. Looks like we had the experiment shows us something, but it doesn't really excite us much.
Okay.
So when we put the two solids together just by themselves, we would say our result would be we didn't really observe anything.
Okay. And that's still part of science, right?
Sure.
I mean, you can, try two things or whatever else. Just because it didn't do anything doesn't mean that you haven't learned something. So, all right. So
now, Mr. Van Grandel, we have two solids there that we don't want to waste as scientists. What can we do now?
what if we've already combined the phenol red with these guys and saw what happened there. What if we kind of did part of the phenol red, which was actually the water part?
Oh, so just the water, not the phenol red.
Yeah.
Well, we happen to have a water bottle right here. Let's take a look. Let's see what happens.
All right.
Beautiful.
All right. So now we got these guys together.
Ooh.
Oh,
What?
we got. You can even.
Can hear it.
You can hear it.
It's definitely fizzing. Do you feel a hot temperature at parts or a cold temperature? Do you feel both temperature changes?
Yes. Yeah, this side over here is kind of cold, and this side is getting warmer.
Oh. So we see both a temperature increase, a temperature decrease, and we got bubbles. There's one thing we're not seeing, though. You guys can probably think at home what that is.
Well, everything still looks, color-wise, still looks pretty white.
Okay.
But
So
we're still fizzing here.
beautiful. So now we have a result when we mixed calcium chloride, sodium bicarbonate, and water. So 3 of the 4 chemicals together. Very good. So you should be marking down your data table.
All right, back again. Here, all right, so we're gonna go with our third little get together, and we're gonna go with the calcium chloride, and we're gonna take that, and we've already tried it with another solid, so we're gonna actually try this with the water and see what happens.
So just the water. Okay. So in our data table, then we'd be marking down, we'd be putting a check mark with calcium chloride, and then a check mark with just water. So mixing 2 substances together. All right, let me get down in here. All right.
Try to get that air out of there.
What do you notice?
There is definitely, so things are definitely in this bag getting much warmer.
Okay. I don't see a color change. There's no bubbles, right?
No bubbles. It is dissolving a little bit, but the temperature change is certainly getting significantly warmer.
Okay.
Okay.
Very good. So if you're marking, as he gets ready for the next experiment, if you're marking up your data table, when you put calcium chloride and sodium bicarbonate together, or sorry, calcium chloride and just water together, we got the temperature to increase. What are you doing now, Mr. Van Grandel?
Okay, so we're gonna take the sodium
Bicarbonate?
bicarbonate and we're gonna put it in there and try to, again, isolate to see what's going on there with just the water.
Okay.
And let's get a little more. I'm not paying for it.
Mama always said if something's good, get more of it.
All right, so we'll take the water with it, find out what's gonna happen.
Okay.
I'm gonna squeeze it out to try to get rid of everything.
As we're doing this, you guys might notice that we're not really measuring out the amounts because for this experiment, it's what we call qualitative, not quantitative. It doesn't matter about the amount. It matters about the observations you're making. What are you seeing, speaking of observations?
So, yeah, again, you kind of start looking at this thing, there's not much of a color change, right?
No.
It really is, it almost feels like sand still down here, but it's getting colder.
Okay.
So, you know, we had talked on when we put all of them together before about the idea that one was getting, part of the bag was warmer, part of the bag was colder. I think when we put that sodium together with the water, it is definitely turning, the temperature of the solution is getting colder.
Okay, so if we're marking our data tables for this one, sodium bicarbonate and water makes the temperature decrease. Very good.
Here we go. So we got one more round of tests that we've got to do. So we're gonna take the calcium chloride and we're gonna combine it with the phenol red. Don't forget when we talked about the phenol red before, the phenol red is an indicator, but it also includes water. So there's a couple things that are in there. So let's find out what we're gonna see when we get done here.
All right, so we got our calcium chloride. Now we're just going to squirt some phenol red in and we're going to see what happens. Oh.
Ooh. Okay. So, in looking at this, we are getting, you can see on this side, we're certainly getting a color change.
Yeah, but you know what? It's not going to the yellow. It looks like it's maybe a reddish orange.
Yeah.
So there is a slight color change, but that's not the color change we saw before.
No.
Okay, so it's not, we're not going to count that as a color change in our observations. We're looking for a yellow color, and that's not a yellow color. Have you noticed, is it getting warmer or
It
cold?
is certainly getting warmer.
Okay, and still no bubbles though, right?
No.
All right, so we got really one result for this. Even though you see a color change, it's not the one that we are studying. So really, it just made it warm, right?
Yes.
Okay, very good. Let's see what happens with the sodium bicarbonate.
All right.
Oh yeah, good heaping amount there. In goes the phenol red. Now remember guys, as you're watching this, you might see a color in there, but that's not a color change. Remember, phenol red is red. So if it remains red, we're gonna say there is no color change. Looks like it's still a reddish color.
It is still certainly a reddish color. It is getting colder though.
Okay, any bubbles?
I still don't see any bubbles.
Okay. So if we're gonna summarize this last part, when we put the calcium chloride with phenol red, it got warmer. That was about it. And then when we put the sodium bicarbonate in with water, in with phenol red, it got colder.
Yep.
Okay. Thank you.
All right, guys, ladies, fill out your data table, and then we'll see if we can make some observations and inferences of what's going on there.